Okay, several of you had questions on your homework about problem 114 in section 7.4 in your book. So I wanted to just make a quick video kind of explaining the setup and all that. I'm not going to do all the algebra out, I'll leave one or two steps for you guys, but at least to get an idea of the setup and how problems like this work. So I have the book in front of me and it says, a tightrope walker and the balance bar together weigh 175 pounds. Find the magnitudes of the tension vectors T1 and T2, round to the nearest tenth of a pound. And then just to do a rough sketch of the picture, you have a guy right here on a balance beam, and then you have a vector here and a vector here. And let's see, T1 is on the right, that's 12 degrees. So that's T1, and that's a 12-degree angle. This is T2, and that is an 8-degree angle. And then you're told the man and the bar together weigh 175 pounds. And we want to somehow find the value of T1 and T2. And essentially, well, we have three vectors going on here. We have T1 and T2, and then we have the vector representing the weight of the man, or the weight of the man and the bar and all that. And obviously, gravity is going to pull him down, which means you really have another vector right here going straight down with a magnitude of 175. And now, to kind of set this up, we're going to list out all three vectors. So the first one is a vector for the man, so we'll just call it Vm for the vector of the man. In the we're going to use an ij vector to kind of relate everything out. He's not moving horizontally, he's only moving vertically up and down, which means it's 0i. And then in terms of the j direction, his weight is going straight down, so that's negative 175j. And again, if you want, you can also just write negative 175j. You don't need to write that. But there we go. There's the vector of the man. Now, let's see. Well, for T1, we can use a formula we have for writing a vector T1. And we'll write, I'll do them in different colors so we can keep them straight. For T1, T1 is equal to the magnitude of T1, which is what we're looking for, times cosine of the angle, 12 degrees, I, plus the magnitude of T1, times the sine of the angle, 12 degrees, J. Now do the exact same thing in a different color for T2. So T2 is equal to the magnitude of T2 times cosine, and here you have to be careful. There are different ways to set this up. To do it more or less the way your book does it, remember the angles for these vectors here start from the horizontal over here, which means we don't take the cosine of 8 degrees, we take the cosine of 172 degrees. Times I plus magnitude of T2 sine of 172 degrees, J. And again, I would point out, if you kind of keep track of what you're doing and understand it, you could just say that this is negative because it's over there, and then use cosine of 8 degrees, and put a negative out in front because it's going to the left, which is negative. And you could do that right here, and that would be fine. If you actually do it without that, and you use 172 degrees, the cosine of 172 degrees, because it's in the second quadrant, is negative. So there's a negative sign here. You can either write it out in front and write cosine of 8 degrees, or just write cosine of 172 degrees. It's up to you, it doesn't matter. This is the way the book does it, so that's the way we're writing it out. Now, we have these three vectors right here, switch colors again, and we want to equate them. The man is on the balance beam, which means logically he is balanced. He's not moving other than the vector going straight down, which means all of these things have to be equal. So we can equate them. Start with the i's. If we use the I components, then 0i has to be equal to the sum of these two vectors, which is magnitude T1 cosine 12 degrees plus magnitude T2 cosine 172 degrees. And then do the same thing with the j's. So let's see. In the j direction, he's negative 175j has to equal magnitude T1 sine 12 degrees plus magnitude T2 sine 172 degrees. Now it's just a matter of essentially solving a system of equations. We have two unknowns, magnitude T1, magnitude T2, which are the two things we want. You can solve it however you want, substitution, elimination. Just to kind of set up the substitution, right here. That's just 0. I'm going to drop the i's and the j's now because they don't really matter. So right here, that's 0. So I'm going to subtract the magnitude T2 over. And we get negative magnitude T2 cosine 175 degrees equals magnitude T1 cosine 12 degrees. This is going to get a little bit messy because of the size of my board, but we can deal with that. Now it's just substitution, so solve for magnitude T1. Divide it over there, divide cosine 12 over there. So we get magnitude T1 is equal to negative magnitude T2 cosine of 175 degrees divided by cosine of 12 degrees. And I would point out the magnitude of T1 has to be positive, but the cosine of 175 is negative, that magnitude is positive, this cosine is positive, and there's a negative out in front. So the negative that will come out of here will cancel with the negative there and make it positive, which is what you want. Now, you have that. That's magnitude of T1, so substitute it in right there. And you'll get negative 175 equals negative magnitude T2 cosine 175 degrees all over cosine 12 degrees times sine of 12 degrees plus magnitude T2 sine of 172 degrees. And now, this is just one equation with one unknown, magnitude T2. You guys can all do the algebra and solve it up. It looks messy, but keep in mind, that's a number, that's a number, that's a number, that's a number. You can just throw it all into your calculator and then combine these two when you figure out what number this is and what number this is. Combine them, or I guess do this one minus that one since it's negative. And then whatever you get, divide it over to the other side and you'll have magnitude of T2. Once you have magnitude of T2, stick it in right there, and it's all for magnitude of T1. These problems are pretty straightforward, pretty standard as far as creating these equations for your vectors in terms of I and j, and then relating them, the I components, the j components, and doing some type of system of equations approach to solve them. So I just wanted to make sure you guys understood how to set them up and solve them. If you have any other questions, just let me know. Like I said, a few people asked questions about this on their homework, so I just made this video. If there's other questions about homework, let me know and I'll make more videos for those questions too.